Why is making chips harder than making atomic bombs? You'll understand after watching the video. To make chips, the first thing needed is a wafer. Sand is melted at about 1800 C refined to remove impurities. Then boron is added to change conductivity. Then keep heating and put a crystal seed into the molten silicon. When the seed touches the hot liquid silicon, the surface cools instantly. As it rotates and is pulled up, the silicon sticks and solidifies. Finally, a high-purity silicon rod is obtained. Then it's cut into wafers thinner than 1 millimeter. The cut wafer isn't smooth, so grinding and polishing are done to make it flat. Since wafers are delicate, an oxide layer is added to avoid contamination. This is oxidation equipment. Every 25 wafers are in a box sent in by tracks and placed by robotic arms. Oxidation begins by injecting oxygen. Coils heat up and oxygen atoms react with the wafer to form insulating CO. Next is lithography, the hardest step before lithography coating is needed. The wafer is spun to spread photoresist evenly. After coating comes lithography. An EUV machine, one of the most precise, uses extreme UV light, reflected and shrunk by lenses, then shines through a mask onto the photoresist. The mask works like a stencil with circuit patterns light passes through. Imprinting patterns onto the photoresist, exposed parts become soluble. Next is development. The wafer is soaked, soluble resist is washed away, unexposed parts remain. But this pattern is only on photoresist. To etch it into silicon, etching is needed. Dry etching is common. The wafer goes into an etcher with CF and O plasma reacting with exposed areas, while resist-covered areas stay. Thus, the mask pattern is etched onto the chip, but oxide is removed, so deposition is needed. The wafer goes into deposition equipment with silane gas and plasma. Hydrogen leaves, silicon stays, forming a protective layer to improve properties. Iodine implantation is done. Ions are accelerated by fields into the wafer. By now, many houses are built on the wafer. To connect them, metal filling is done. Billions must be linked like a giant city. Real chip making is far more complex with many nanometer scale steps. Repeated until the wafer is complete, then the wafer is cut into chips, packaged, tested, and used in electronics.